All right, this is section 3.4, exponential and logarithmic equations and applications. So let's start with remembering the one-to-one properties. For any exponential function, f of x equals b to the x power, if b to the u equals b to the v, then u equals v, right? If two things have the same base and they are equal to each other, their exponents must be the same. Same thing goes for any logarithmic function. If f of x equals log base b of x, then log base b of u equaling log base b of v implies that u equals v. Two logarithms with the same base that are equal to each other, the things inside the logarithms must be equal. So we are going to use that idea. 2 to the x power equals 32. Well, 2 to the x power, let's rewrite 32 as 2 to a power. 2 to the fifth power is 32, which means that x must equal 5 because I rewrote them with the same power. Natural log of x equals natural log of 3. Both natural logs, which means the insides must be equal. X must equal 3. Now we'll get a little crazier. 1/3 to the x power equals 9. So we want to write 9 as 1/3 to a power. Well, 3 squared gives me 9, but 1/3 squared would give me 1/9. So I need a -2 power, which means x must equal -2. There we are. E to the x power equals 7. Well, I don't know how to write 7 as a power of e. But I do know that I can rewrite this as a logarithm. A log with a base of e, which is a natural log, of 7 equals my exponent of x. I could say x equals the natural log of 7, or plug that in my calculator. X is approximately 1.946. Natural log of x equals -3. Well, that's not a log equals a log, but I could rewrite it as an exponent. The base of natural log is e. The power would be -3 to equal x. Type that in my calculator, e to the -3rd power. X is about 0.0498. Log of x equals -1. Well, that's a base of 10, so 10 to the -1st power equals x. That means x is 1/10. Log base 3 of x equals 4. Well, again, I would rewrite this as an exponent. My base is 3, the exponent is 4, it equals x. 3 to the 4th power is 81, x is 81. E to the x power equals 7. Wait a second, didn't we just do this one? We did. Boop. Some steps to solve exponential equations by using logarithms. Step 1, isolate the exponential expression on one side of the equation. Means get all the other numbers out of there. Take a logarithm of the same base on both sides. Use the power property of logarithms to bring down the exponent. Solve the resulting equation. If you're solving an equation with e, use the natural log instead of the common log. So, let's look at it. We are going to solve this one. Ooh. Starting with my trick one? I don't want to start with my trick one. Let's go over here. We're going to solve this. We want to get the exponential part alone first. So I need to get the 3 out of there. I'll divide both sides by 3. I now have 2 to the x power equals 14. Now I take a logarithm of both sides. The base should match the base of my exponent, so I want to log base 2 of both sides. The power property means that I'm bringing my exponent down out front. X times log base 2 of 2 equals log base 2 of 14. Well, log base 2 of 2 is 1, so I have x equals log base 2 of 14. And to figure this out, we use change of base, common log or natural log of 14 over the same log of the base, which is 2. So let's see here. Log of 14 divided by log of 2. X is about 3.807. To double check that, let's grab my calculator, go back to the original problem. 3 times 2 to the power of 807 out of the exponent, close parentheses, 41.989, which is very darn close to 42. We rounded our answer, so it'll be just a tiny bit off when we check it. Now let's look at this one. I have e to a power equals e to a power. Well, to undo an e, we use a natural log. So I take natural log of both sides. And then I follow the power rule to bring those down out front. So negative x squared times the natural log of e equals negative 3x minus 4 times the natural log of e. Well, the natural log of e is 1, so we have negative x squared equals negative 3x minus 4. Now I have a quadratic to solve. Add my x squared over. I get 0 equals x squared minus 3x minus 4. Try to factor that. X minus 4, x plus 1. So we get x equals 4 and x equals negative 1. Double check our answers to make sure they work. Let's make sure. E to the negative 4 squared and e to the negative 3 times 4 minus 4. Look at that, those matched. Same thing, e to the negative 1 squared and e to the negative 3 times negative 1 minus 4. Sorry, I wasn't showing that. But look at that, they both matched. They're both solutions. Perfect. And now for this one. This one has more going on than just e's, so I can't just take the natural log of both sides. Instead, we need to factor. And factoring here is kind of wonky, because we usually take our first term and it's something squared. Well, e to the x power squared is e to the 2x power. So we are actually going to factor with e to the x and e to the x. Notice that e to the x is the center term. So I need two numbers that multiply to 2 and add to 3, plus 2, plus 1. Set both sides equal to 0, or both factors equal to 0. Subtract e to the x power equals negative 2, e to the x power equals negative 1. Now, when will e to a power ever equal a negative? Never. We could take the natural log of both sides, but we would find that there's actually no solution to this. Man, all that for nothing. Now we're going to solve logarithmic equations by using exponential form. So given a logarithmic equation, isolate the logarithms on one side of the equation. Use properties of logarithms to write it in one logarithm. Or a logarithm equals a logarithm. Either way is fine. Write the equation in exponential form, solve it, and check your solution. So, natural log of x equals 3. Essentially what we're going to do is we're going to raise both sides as a power. Natural log has a base of e, so we'll go e to the power of natural log of x equals e to the third power. Well, e to the natural log of x power is just x. E to the third power is approximately 20.086. And then we're done. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. Well, both sides are log base 3. Technically what we're doing is making them both the exponents on a base of 3. But the shorter way is to say, all right, 5x minus 1 must equal x plus 7. That's that 1-to-1 property. Now we just solve, subtract an x off both sides. 4x minus 1 equals 7. Add the 1 to both sides. 4x equals 8. And divide by 4. X equals 2. Now before you move on, it's always good to double check your answers, because if you get a negative inside of your logarithm, that is an extraneous solution. 2 does not give me a negative in there, so we should be good. Our answer is x equals 2. All right, log base 6 of all this. Well, the first step here is to get it into one logarithm. You can do one logarithm on each side. Subtraction becomes division, so we have log base 6 of 3x plus 14 over 5 equals log base 6 of 2x. All right, our one-to-one property says the insides of these logarithms must be equal. And now we'll solve. I'll multiply both sides by 5. 3x plus 14 equals 10x. Subtract my 3x over. I will get 14 equals 7x. Divide by 7. X must equal 2. Double check that that won't give me a negative inside any logarithms. It doesn't. There's our answer. 5 plus 2 times the natural log of x. All right, we're going to start by isolating our logarithm. I'm going to subtract 5. I have 2 natural log of x equals negative 1. I'm going to divide by 2. I get the natural log of x equals negative 1/2. And then we make it a power. E to the natural log of x equals e to the negative 1/2. X equals e to the negative 1/2 power, which according to my calculator is 0.607. 2 times the natural log of 3x equals 4. All right, first step is to get our logarithm alone. So I'll divide by 2. Natural log of 3x equals 2. Now we raise it to a power. E to the natural log of 3x equals e squared. Well, 3x must equal whatever e squared is. E squared is about 7.389. Divide by 3. X equals about 2.463. Now, one tip when you do problems like this. In my calculator, I grab it, I say, okay, what is e squared? Then I have something to write down for my own thought process. But I don't retype the number, I just type in divided by 3. It'll say ants divided by 3, boom. Because every time we round, we get a little further from the actual answer. So you want to try as hard as you possibly can to avoid rounding until the very end. All right, let's do a couple more. This one I have a bunch of different natural logs. Let's condense. Well, I have addition over here, so we'll take the natural log of x minus 2 times 2x minus 3. Over here I have a 2 out front, but I can only deal with this if it's just a log. And it's not like I can divide both sides by 2. I will make that a power. Natural log of x squared. They're both natural logs. I set the insides equal. I'm going to multiply this out at the same time. So 2x squared minus 3x minus 4x makes minus 7x plus 6 equals x squared. It's a quadratic. Get it equal to 0. So we have x squared minus 7x plus 6 equals 0. Factoring gives me x minus 6 times x minus 1. So my solutions are x equals 6 and x equals 1. Double check, always. If I plug in 6, I get positives all across the board. If I plug in 1, I'm taking the natural log of negative 1. I can't take a natural log of a negative. X equals 1 is an extraneous solution. So it's very important that you always check for those because they do pop up. And one more for this video. Natural log of x equals x squared minus 2. All right, what are we going to do? Well, the only way to get rid of a natural log is to raise it as a power. So I have x equals e to the x squared minus 2 power. Well, how do I get that out of there? We start to do some crazy wonky work, right? This one is not something that we would generally encounter, but some work we could do on it. If I'm subtracting exponents, I can make it division, right? I could make it e to the x power, but again, that doesn't help me. I could do a lot of things, but nothing really helps. This is the type of problem that I would say your graphing calculator would be the best bet. Plot two different lines, natural log of x and x squared minus 2. Oh, and my window's all wonky. Zoom 6. We are looking for where these intersect. Well, they intersect, it looks like when x is 0, but we can't take a natural log of 0. So I'll second calculate, intersect. First curve, yes. Second curve, yes. Guess, go over by that guess. They intersect at 1.564, 0.4475, blah, blah, blah. That means that x must be that x value, 1.564. To double check that, leave this, natural log of 1.564. There we go. And 1.564 squared minus 2. They're pretty darn close to the same value. No problem there.